Good evening, friends. Welcome back to Coding Hives. This is Rasina with you. Hope you all are doing good. So, in today's video, we are going to learn about abstract classes in Python. So, what is meant by this abstract class? Let us start with a simple example. Imagine you are designing a house, and every house must have basic things like doors, windows, and a roof, right? But how those doors and windows look will depend on who built the house, right? So, in Python, abstract classes work in the same way. Like they define the basic structure, like what must exist without giving all the details. So, an abstract class is like a template or a blueprint. It says these are the methods you must include in your subclass, but it does not tells you exactly how those methods should work. So that is up to you to decide in the child class. Clear? So now, why do we need these abstract classes? The thing is consistency, like every subclass must follow the same structure. So this is helpful when working on big project with many developers. So there will be a consistent structure we can follow. And the second point I can say is flexibility. Like you can define some general behavior in the abstract class and leave the details for subclasses to decide. And the third one is reusability. As you know, inheritance, we are achieving reusability by inheritance, right? So in abstract classes, it also reduces this repetition. So the shared logic can stay in the abstract class while the specific parts go into the subclasses. Okay. So now I will explain how we can create abstract classes in Python. So by default, there is no way to use abstract classes in Python, but we have a module that is named ABC module, that is abstract base class module. So using that module, we can achieve this abstract class functionality. So for that, we need to import ABC. I mean this module, ABC module, that is abstract base class module. Okay. And we need to inherit from that ABC, our classes. And we also need to use a decorator named as abstract method decorator to mark the methods that every child class must implement. Okay. So let's see an example so that you get an idea or clarity like how these things work. Okay. So imagine you are going to create a program to control different types of vehicles. Okay, vehicles. So here every vehicle must be able to start and stop, right? So, but how they start or stop depends on the type of vehicle. Like bike starts in another way, car starts in another way, right? So with that we can define the child class. So first we need to import, as I told, from abstract base class. So here we are using ABC, that means abstract base class. Okay, from ABC we need to import this module, import, that is ABC. This is capital letter. Okay, and also we need to import one decorator, that name is abstract method. I mean the methods or the functions which we are going to write inside this class are known as this method, and this abstract decorator ensures that this is the abstract method. Okay, so now I'm going to create my base class, I mean the parent class, and here my base class name is vehicle. Okay, and which is used inheriting from this ABC. Okay, that is abstract base class. Okay, now here I am declaring whatever function we need to use as an abstract method. We need to use this abstract method decorator. So here, this is the way we can use this decorator at abstract method. Okay. And here I can write my function name. So my first function is start. This is the function to start a vehicle. Okay. So here, as every time we are writing, this is the first argument, right? Self. And here I'm simply making a pass, like this implementation I am writing in my child class only. So this base class, this abstract class, just giving a structure, we can define this whole working part in this child class. Okay, and also I have another function that is also an abstract method. The name is stop. Okay, so this is my function. to stop the vehicle. So here also I'm not writing anything. We will write the implementation in this child class, in the coming child class. This is the parent class only. Okay. So I hope you understand what is this base class means. This is the class vehicle and it has two abstract methods, the start and stop. We will write the implementation part in this in the coming child classes. Okay. So now we are going to implement two classes. I'm going to implement two classes named car and bike, okay, which is inheriting from this vehicle, and we will give our own version of this start and stop function. Okay, so for that I'm going to write class, then we can give car, then which is inheriting from this vehicle, right? So vehicle is the parent class and car is the child class. And here I'm going to write this function start. Okay. So this is the abstract method we declared in the parent class, and here we are going to implement the start function. Okay. So here I am writing something like we can say something like car. Car is starting with a key. I'm giving something. Okay. So this is my start function for this car, and I'm also writing our stop function also here. So for that I can write return. I can write like car is stopping with the brakes. I can write something like that. Car is stopping with the brakes. Okay, so now I'm going to declare my next class, that is my bike. Okay, so this is also inheriting from our parent vehicle, and here also I am using that abstract methods, that two methods we already defined here, right? This start and this one, this start and stop, I am also going to implement in this bike class. So here I can write def start, then self. Here I can write like how we are going to start a bike. Like bike is starting with a button, right? So I can simply say bike is starting with a button. Okay, same like we can write the stop also. So I'm just copying here, just pasting here, and here car is stopping with, I think there is something like a disc brake, right? So that also I wrote here. Clear? Now I can test this code using some object, right? So for that I'm going to create an object of car first. Okay, so first I created an object of car. Then I am going to create an object of bike class also. So now if I'm going to print something like print car dot start. Okay, car dot start, this is function bracket is needed. Okay, then print car dot stop. Okay, now we can check it here. You can see, so car is starting with a key, car is stopping with a brake, right? The same like we can use for this bike also. So I will just copy this code here, then pasting here. Here our object is bike, right? And here also our object is bike. So you can see the output we are getting something like this, like car is starting with a key, car is stopping with brake, bike is starting with a button, and bike is stopping with the disc brake. Okay, so here the car and this bike provide their own versions of start and stop, right? We just simply give a definition like a structure for the function we gave in this vehicle base class, but in the derived class only we give the implementation part, right? So car and bike have its own version of start and stop function, clear? So this makes this code more flexible. So we can add more vehicles like airplanes or boats, and they will still follow the same rules like start and stop methods. Okay. So now I will tell you what happens if you break the rules. Okay. There is a rule, right? For this abstract classes and abstract method, there is some rule. But what happen if you break the rules? That also I will tell you. Like if you create a child class but don't define the abstract methods. Like here you can see in this base class, this is the base class, right? Vehicle, and it has two abstract methods, right? So now I am telling if you are creating a child class, here in this case there are two child classes are there, car and bike, right? And these classes have the same abstract methods here. If we are not defining these abstract methods, then what will happen? That also I will show you. In that case, Python will throw an error. So let us see an example. Okay, I have a class. I can say incomplete or something like this. I can give incomplete vehicle. Okay, incomplete vehicle. Okay, this is some example. Like what happened if you are not giving that if you are not using this abstract methods which is in the vehicle. Okay, that I am going to show you here. So here I have a start function. Start function I am writing here, and I am returning something like return. I can start, but I cannot stop. Like I am not planning to write a stop function here, but I cannot stop. I can't stop. Okay. So this is my start function, but here I am not writing this stop function. Okay. So now if I am trying to call this function, I will make these all things come in. Like you got this idea of car and bike, right? So now I'm going to create an object of this incomplete vehicle. So I'm giving something like incomplete vehicle equal to this one incomplete vehicle. Okay, and here I am going to vehicle dot start. I'm going to just simply call this function. I'm running this. You can see here we got some error like you cannot instantiate abstract class incomplete vehicle without an implementation for abstract method stop, right? So whatever methods, whatever abstract methods we are giving in this base class, that must be in this child class. So that is mean by flexibility, right? Like the structure should be consistent in everywhere, that is the thing. But the implementation we can do whatever we want, but the function should be there. That is the rule. Okay, so we cannot break the rules here in this case of abstract classes, clear? So that is the thing, Python forces us to define all the abstract methods in the child class. This and ensures our code is more consistent, clear? So that is why I told in the beginning, like this abstract classes help us to be more consistent with this code. Okay. Now I will tell you one more thing that is related to this abstract class. That is, you may be having some doubt like abstract classes can also have methods with the full implementation. Like subclasses can use this directly or override them if needed. I will make a comment of these things all here. So now here I'm using this vehicle class only, and here I'm going to define a function named fuel. Okay, so this is a function. I'm just returning something like what we can say this vehicle uses fuel, simple on message. So the difference is like you can see these two methods are abstract methods and this fuel is the normal function. Okay, and I wrote the implementation here. So the remaining child class is the same only, like class car vehicle I have here, then class where bike is also there. You can see if I'm going to call this car dot fuel, like we are getting this vehicle uses fuel, right? The same we can also access using this bike dot fuel, but we cannot access or we cannot create an object of this vehicle class. Okay, that is one important point you need to note in your mind. Like we cannot create an object of a abstract class. Clear? So we can only create objects of child class. Okay, so we can access this fuel function using the child class object, like using a car and bikes object. Okay, so we are getting the output like this. So we learned what is meant by abstract class. Abstract classes are like blueprints that define a rule for child classes, and it uses the ABC modules to create them in Python. And abstract classes cannot be used directly. Okay, and they make our code more organized and easier to manage in large projects. So that's it for today's video. Thank you for watching. Have a nice day.